In 1859, there was a geomagnetic storm so big that the aurora was visible in Hawaii.
Holy wow.
They had telegraph systems. Some of the operators were reported to be able to send messages even when they weren't plugged into their batteries. They were just using the current generated from this geomagnetic storm. This thing was the largest geomagnetic storm in recorded history. It was called the Carrington event. A solar superstorm like this is not unusual. It could happen again today, and it would be way worse, like way worse. It would cost more than the top 10 natural disasters in the US combined to recover from. So yeah, these solar superstorms are getting more and more likely leading up to 2025. So first of all, that event is the same type of event that causes the aurora. The thing that we were chasing last night, the thing that we want to see tonight. Ever heard of solar cycles? The sun has these periods of activity where there's a period of when there are the most sunspots and then periods of a little bit of calm about once every 11 years. Why every 11 years? Any guesses? Like what happens every 11 years?
Seems very like nature to move in waves.
I was like, maybe it's a coincidence. It turns out that it's because on average every 11 years, the sun's north and south pole switch. So the Carrington event happened coming into the maximum of the 10th cycle of the sun, the 10th since 1755 when we started recording that the sun came in cycles. No one noticed that until they were able to see sunspots. Remember when we went to Mount Wilson Observatory and they were drawing sunspots on paper? That was some of the first telescopes that were ever used to look at solar spots. Do you even know what the sunspots are? Sounded like a very condescending question.
No.
Have you ever seen a picture of the sun with like all these lines? Those are all magnetic field lines. And if you have a ton of them going into the sun, that's where you'll see a sunspot. Sometimes those magnetic field lines can get like wrapped around each other and twisted, and sometimes they'll just like snap and break into more of a smooth kind of configuration. And when that happens, we see a solar flare. This pop, like this release.
I was really surprised because I just hadn't pictured it yet until we started talking about it. But when you said we missed a storm, it shot off in a direction.
It shot off in a direction. So every 11 years, you have more of a potential for a hit of a solar superstorm. And the last time, it missed us by 9 days because the sun was just facing the wrong way. So yeah, 2012 is the near miss where a Carrington-sized event just missed Earth.
Wait, it happened in 2012?
2012.
The end of the world year? Remember that?
Oh yeah.
That's so funny.
Yeah, but the end of the world just missed. And it missed us by 9 days because the sun spins about every 25 days. It just happened to be not facing us by a 9-day miss. So we're now in the 25th solar cycle and we're coming into the peak of it. You get increased solar flares.
Gotcha.
And you also get increased CMEs, or coronal mass ejections. Do you know what that is? It's like sun vomit. Whenever you get that snapping, you release a lot of mass that shoots material off into space that we call the solar wind. It literally is mass because a bunch of SpaceX satellites just fell out of the sky when there was a big solar wind event because the atmosphere literally became thicker. It became too dense and slowed down the satellites to the point where they couldn't recover and they fell down to Earth and burned up in the atmosphere.
Oh.
That just happened.
Crazy.
So it's a big deal when the sun's magnetic field flips. For us, what it means is these periods of heightened and potentially extreme solar activity. So the peak of the solar cycle will happen in 2025.
Oh, cool.
So that means increasing solar activity right now, which means a higher chance of seeing auroras. We've got some solar wind coming, a geomagnetic storm coming. The aurora is gonna come. Oh, dogs!
We went dog sledding!
What would mostly happen when a solar storm occurs is that fortunately nothing happens to our bodies, but things do happen to our electrical systems because it's a bunch of charged particles. During the Carrington event, this was before even the US Civil War, so there were only telegraphs. And the telegraph systems were sparking. It's like using your computer and getting shocked through the keyboard. Some of them were catching on fire. Some people were seeing like these amazing swirling colors, but it was visible in Havana, Cuba, Cuba, in Key West, Florida. And some people thought that their cities were on fire. So it was a predominantly red glow all over the sky. Before we find out how solar superstorms affect us, a quick message. Thanks to Omaze for sponsoring this video. Omaze is bringing you the opportunity to win Tesla's most sought after, top of the line flagship SUV and support Give Power and 501c3. More about them in a minute. So supercar stats don't immediately come to mind when you hear SUV, but that's exactly what the brand new Tesla Model X Plaid brings. Think versatility, but with style and power, and an all new interior and updated exterior styling. Whatever you want to do, wherever you want to go, be the first to get there with 1,020 horsepower taking you a quarter mile in 9.9 seconds and 313 miles of range. And then sit back and watch a movie under the stars with your 17-inch cinematic display and glass panoramic roof. The wait list for this Tesla is currently 6 months, but you can jump that line faster than this SUV can go 0 to 60. That's 2.5 seconds. Your donation will support Give Power and 501c3. Give Power is on a mission to help the roughly 2.2 billion people around the world who do not have access to safely managed drinking water. 501c3 is a new type of nonprofit for the younger generation focused on energy, food, water, and shelter. For your chance to win a Tesla Model X Plaid and support a great cause, go to omaze.com/physicsgirl. And now back to solar superstorms. So when a solar storm occurs, all this mass is ejected from the sun and heads toward us. Do you know why that creates the aurora?
No.
Oh, beautiful. Okay. Do you know why neon signs light up?
Neons? No.
When you put a high voltage across a gas, that gives the electrons in the gas enough energy to fly off. When the electrons come back together with the gas that they flew off of, it'll emit a little bit of light. That's it. With the aurora, it's very similar. You've got all this mass of hot plasma raining down on Earth from the sun, and they'll bump electrons off of the gas in the atmosphere. And then those electrons will come back together with their atoms, and they'll release light.
So the electrons bump off the gas in the atmosphere.
Exactly. Earth is like a neon sign. In fact, you can actually detect the rays coming down from space with fluorescent light bulbs. There was a guy at CERN that took a fluorescent light bulb and he was able to see like, oh, we're getting cosmic rays coming down because he's getting flashes of light inside the fluorescent bulb.
Oh, cool.
Yeah.
So we're just blown away at the spectacle of like the Earth's defenses as it keeps like
destructive
solar waves hitting us.
Exactly.
We're like, ooh, pretty.
Like, oh, it's so gorgeous. Do you know what causes the different colors? You change the gas that's inside the tube.
Whoa.
Remember how they talked about there's sometimes purples and reds and greens and they happen in different layers of the atmosphere? The reason why is because it's different gases at different altitudes of the atmosphere.
It's where all those pretty shots of space come where you can see the aurora.
Yes.
Sticking off like hair. It's like
exactly. So we've been tracking the northern lights for the last week because we've been here in Fairbanks, Alaska trying to see them. But there's a website we've been following where you can look at the KP index. Basically 2 upward you can kind of see the northern lights. Then a 5 is good northern lights. That's what we got last night. It was amazing. They kind of correspond to storm classes. So a KP5 like last night is actually considered a G1 class storm. So that could potentially do some damage. It could cause your lights flickering, minor satellite disruptions. And then G5 is potentially widespread power outages, failures of transformers. They just build up too much charge to the point where they'll blow, create fires, potentially have grid blackouts, electrical grid collapse. So this entire city could just collapse. Not the buildings, but we would lose power in the entire city. And something like that happened in 1989 in Quebec. There was 6 million people that lost power and it was not brought back up for 9 to 12 hours. Again, that wasn't even the largest type of solar storm that could happen. You wouldn't be able to track on your GPS. You have no refrigerator. You have no Xbox. You have no washing machine, no dryer, no computer. You wouldn't be able to charge your vehicle if we're moving more toward electric vehicles and the grid goes down, which is terrifying. Anything that's plugged in, or your computer might get fried, your camera might get fried, if it's plugged into something. Chances are the smaller electronics wouldn't be as affected. If there's evidence of a solar flare incoming, one of the best things to do would be to unplug all of your shit. So the economic impacts of something like the Carrington event, $2.6 trillion is one of the estimates. $2.6 trillion. And it could potentially take 4 to 10 years to recover from.
Why?
Because the grids go down. Once you damage that much critical infrastructure, it takes a long time not only to make that, but to repair it all. It's a serious problem. This is something that scientists have been warning about for such a long time. One of the reasons that putting safeguards and boosting our electrical infrastructure is so crucial. We think of this as such a modern society where like the problems of the past don't affect us, but in fact, this is a problem that affects us more now because we rely so much on electrical based technology. It wouldn't have affected Cleopatra.
I'm buying some candles tonight.
I'm not a doomsday kind of person, but like we need to boost our infrastructure. Scientists want to figure out how likely it is for one of these storms to hit us again. And they looked at the last 150 years and they found that there were 6, quote, great solar superstorms, which is the most powerful type of solar superstorm. Because this is not an unlikely event. Anyway, that's how the Aurora works. These are the biggest solar storms in recorded history and the near misses. So.
Well, I said this before and you laughed, but that is so much more interesting than I thought it would be.